Okay, so this video is just to kind of finish up that third question of practice number 7. So that's because the video didn't fully work through each part. There were solutions, like a PDF solutions, but that doesn't always help as much. So I'm just going to kind of go through and do each of these. I probably will do it over a couple of videos. So if I don't get to the particular part that you're looking for, do just go ahead and check out the second video. All right, so let's go ahead and take a look at part A. So let's take a look at the question actually just in general here. So when we look at just kind of the diagram that they're giving us, so let's just kind of focus on that real quick. So I see that I have my f of x graph, I also have g of x, and they intersect at the point C, g of c, so this guy right here. And so we know that g of x is equal to x, right? So we know that. And so that also means that we know g of c, yeah? So then that means g of c is equal to c. So the first thing I would do is just kind of rewrite this ordered pair here. So instead of calling it c g of c, just call it c comma c. Because that would be a whole lot easier, right? Since this equation is y is equal to x. And that way it's a little less cumbersome. So when I refer to this common point of intersection, my x value is c as well as my y value. Okay? All right, and also keeping in mind that f of x is this value at 0 and 1/2 c, or c over 2. Okay? All right, so let's read the question. So for this question here, it says f and g are twice differentiable. That just means you can take the first derivative and you can take the second derivative. So for all real values of x, where g of x is equal to x, so again, we already kind of talked about that, but just as a reminder, don't forget that g of x is just the same as x. So a portion, so only a part of the graphs of f and g are given above, and it is known that the average value of f, so the average value of f, on the interval from 0 to c is equal to c. So let's go ahead and figure out, well, what does that exactly mean? Because we'll probably need to use that later on. So let's go ahead and deal with just that piece first. And I will do that off to the side here. So for that average value, so if you don't remember what the formula for average value is, you can look it up on your AB summary card because it is in there. It was also in chapter 4, I believe. Yes, so it was also in our chapter 4 notes as well, so you can look that up there. So the average value of f, so that formula was given as f of, the integral, or let me try that one more time here. So let's do that a little better there. All right, so the average value is the integral from a to b, but we're from 0 to c, so from 0 to c of your function, so f of x dx, over the difference, so b minus a, so in this case c minus 0. And then they tell us that that average value is equal to c, so then that means this is equal to c. And so let's go ahead and simplify that just a little bit. So I'm going to multiply both sides by c, because I feel like it's going to be helpful to know like what that integration piece is going to equal. So then that means the integral from 0 to c of f of x dx is equal to c squared. And so that's probably the piece that's going to come in handy, not so much that it's an average value, but just what is the integral from 0 to c, okay? All right, so part A. So they want us to find the area. So we're looking for the area of the region R in terms of C. So we're looking for this area in here. And they want it in terms of C, meaning we actually have to do the integral. We can't just leave it as a setup of an integral. So make sure that you're always paying attention to that distinction. So oftentimes they'll say, set up the integral, do not evaluate. And so because they're actually asking us to find that area in terms of C, that means we probably need to go further than we normally do, okay? All right, so let's go ahead and take a look at that area. So we know area is integration, and we know for our limits, we're gonna go from left to right. So our left side here is at 0, and then that right side right here is at C. So we're gonna integrate from 0 to C. And we want to do top minus bottom, right? So I'm just going to pick a random segment, so we'll just call that. And that top dot is defined by f of x, and then minus, and then that bottom dot is defined by g of x, which remember is just x. So g of x, which is just x. So top minus bottom, and then of course with respect to x. So I'm going to go ahead and split this integral. So I'm going to integrate this from 0 to c of f of x dx, and then subtract the integral from 0 to c of x dx. And so this right here is equal to c squared. And that, again, remember, is when we did that average value idea here. So we have average value was very helpful in identifying what the integral from 0 to c is. So we know that's c squared, and then minus, and then now we have to integrate this piece right here. So now we need to figure out what that integral is, and that's just going to be power rule. So that's an implied 1 there, so we're going to add 1 to the power, and then divide by the new power, and then we're going to integrate that from 0 to c. So that integral would be c squared, and then minus, so substitute in c first, so I'm going to group that so I don't forget to distribute the negative. So that would be c squared over 2, and then minus, evaluate at 0, 0 squared over 2. And then I can just leave it like that, right? I don't need to solve it any further. And like that would be good enough, and I wouldn't want to keep going. I'm just going to say that's good, right? So we're going to call that done. And move on, right? We want to make sure that we spare every second that we can to actually do more work for more points. So keep going on this one won't earn me any more points. So done, move on, okay? All right, so let's go ahead and take a look at B. So this one, okay, so for question B, so they're saying that the region R is the base of a solid whose cross-sections perpendicular to the x-axis form rectangles. So we're doing cross-sections. So in order to do cross-sections, we use area formulas. So we have rectangles, and we know the area of a rectangle is base times height. So that would be what we would integrate, right? That base times height value. Excuse me. All right, and then our height is defined to be f prime of x. So our height is f prime of x. So in this case, we can modify that area formula just a little bit more. So base times f prime of x. And then we want to find the volume of the solid in terms of c. Okay, so just to kind of go back to a couple of things here that we had on the previous slide that I may or may not use, I'm not really sure. But we had that the area from 0 to c of f of x was equal to c squared. We know this ordered pair is actually c comma c, and we have that g of x is equal to x, and I think that was it, but let me double check. Yeah, that looks like it. Okay, so that is just information from like the previous. All right, so here we go. So cross section. So this is going to be our formula here. So we're doing the cross sections of this guy is our base. So our cross sections, what we did for that is same thing. So we're going to do top minus bottom. So we're going to put a dot here and then drop it down to the other edge of that shaded area, which is there. And then this, remember, for cross sections is going to be the base of whatever shape you're using. And so for us, it's the base of the rectangle, right? So that is the base of our rectangle. And so we're going to define that to be top minus bottom. So that would be f of x. And then the base, of course, is on g of x, which is just x. Okay. All right, so our volume formula is going to be the integral. So we're going from left to right. So that would be at 0. And then to here, which is at c. So we're going to integrate from 0 to c of our area formula, right? Because we're doing cross sections, and area formula of our rectangle. And that is base times height. So our base we defined up here. So our base is f of x minus x. And then times our height, which is f prime of x. So just like I did on the past problem, I'm going to go ahead and distribute this out and then solve them independently. So then my volume is going to be from 0 to c, and then I'm going to distribute this guy in. So f of x times f prime of x dx, and then minus the integral from 0 to c of x times f prime of x dx. Okay, so both of these are going to be integration by parts, and the reason I know it's integration by parts is because I have a function and a derivative. So it's an abstract version of integration by parts, but this is definitely the clue here to know that is the fact that we have f and we have f prime. And so that's what we're going to do. So I'm going to do this one over here in red so we don't get those kind of muddled. So then when I look at that integration here, I want u to be my f of x, and then my dv will be the f prime, because I can integrate f prime of x, and that's why I want it to be in that form. So then my du will be f prime of x, and my v will just be f of x. Okay, so again, I'm just doing that left integral though, so keep that in mind. So then when I go to integrate that piece of it, I will have the integral from 0 to c of f of x, f prime of x, is equal to u times v, so u times v. So that's just going to be f of x quantity squared. And then minus the integral of v du. So now I multiply those two guys. So then that will be minus f of x, f prime of x, and then dx from 0 to c. So this is not a technique that we encountered, but what we should be looking at, and so this is going to be very different, but if we got to this point already, we would actually earn quite a few points. So these last like couple steps to finish out probably aren't worth as many points, but if you got to here and you're like, well, I don't know what to do next, like that's okay. Like you got this far, you showed, yeah, I recognize I need integration by parts. So this last little bit, like if you weren't able to do this, do not be like fretting, okay? Because this is like so unusual. So what I am noticing when I do this is that I have this integral here and this integral here, and they are exactly the same. And so the way I want to view this is, let's make it an algebraic equation to solve. So then I'm going to go ahead and add this integral here over to the other side and over to here. And so when I do that, and I go ahead and I combine this left side, so when I take this, right, and I go ahead and combine these two together, I have one integral plus one integral will give me two of them, right? So I'm just going to add those just like I would like terms. But in this case, my like terms are integrals. So that would be 2, 0 to c of f of x, f prime of x dx. And then this canceled, so that is equal to f of x squared. And then I realized I forgot that it's a definite integral, so from 0 to c. And so then now, two more steps. I'll do this in 2 steps. So I have 2 times that integral still. And then I'm going to evaluate at c and 0. So that will be f of c squared minus f of 0 squared. And so let's see if we can figure out f of c. So we do know that. So that's given off of this ordered pair, right? When x is c, g of x and f of x would both be c, because that's that common point there, right? So then this would just be c, so I would have c squared, and then minus, and then f of 0, so f of 0, so that's like right here, so that's that point. So that ordered pair is when x is 0, your y value is c over 2. So then this right here would replace with c over 2 squared. Okay? So that was a lot, right? That was really difficult. So then now all we've done is that first integral, so now we still have to do that second integral. So let's go ahead and we're going to do that kind of off to the side right here. So fortunately this one looks a lot nicer, but it's still going to be a little rough. So still integration by parts, and I know that because I have the derivative in there, right? So u is going to be x, and then my dv will be f prime of x dx. So that integral of dv would be v, and then the integral of f prime would just be f of x. And then the derivative of x is just 1, and then with respect to x, so 1 dx. Okay? So then that integral, so then we would have the integral from 0 to c of x f prime of x dx is going to equal, I have to steal some space over here, so that would be u v, and then it's a definite integral, so from 0 to c, minus the integral from 0 to c of v du, which is just f of x dx. All right, and then let's go ahead and substitute in the c. So we would have c times f of c minus 0 times f of 0. So that's just that part. And then minus, and then we know this, right? This we actually looked at before we even started, right? So that was off of that average value bit of information. So for average value, so we discovered then the integral from 0 to c is c squared. So I'm going to replace this with c squared. Okay. All right, and then again, we know c f of c. So when x is c, our y value is c from that common point. And so I would have c times c. This, of course, is just 0, and then minus c squared. And then c squared minus c squared, of course, is 0. So we still have to kind of put all that idea together. And so then our volume, right, so therefore that volume would be equal to this right here, right, so c squared and then minus c over 2 squared, and then minus 0, right, but I certainly don't need to put that minus 0 in, but that would be the combining of those two equations. So that one was really tough. So even if you got to, say, this piece right here, so you've got like at least your setup, and maybe you showed some sort of integration by parts, like that would earn you at least 1 or 2 points, you know, provided, like, I don't even know how they're going to break up all of this. And I'm guessing like all of this down here probably is only worth also 1 or 2 points, maybe 2. But it's still like it would be like fabulous if you just got to like even that first line of that setup. Like that would be extraordinary. And certainly don't beat yourselves up if you couldn't get anything past that, because this one I would say is a really hard problem. And even if we got to that part of it and I recognized, holy smokes, like how would I integrate that? I would just move on. I say, well, you know, I got the setup, that's +1, and give yourself a pat on the back. And don't, you know, fret or worry or, you know, create any kind of anxiety thinking like, well, but I can't do the rest. That's okay. Like that really, really is okay. All right, so that was B, so that was a doozy. All right, and then let's go ahead and take a look at C and D. So we'll work on C and D as well. Okay, so for this one right here, so this is just the directions restated again. And then I'm just going to go ahead and write in like the little pieces that we already know. So again, we know that integral from 0 to c of f is c squared, and we know this ordered pair right here, let me zoom in just a little bit, is c comma c, right? And then don't forget that this equation is really just y equals x. Okay. So for this one here, so they say the function h is defined by h of x equal to, so they're giving us this equation right here. So here's like a whole new function, and it's defined in terms of 2x squared and then the integral of f. And they want us to find h prime and h double prime evaluated at c over 2 in terms of c. And then they ask you some questions about that. So again, we're going to focus on what we can do, right? So we're going to be very short on time for this test, but we're going to do always at least, you know, whatever we know for sure, at least do that part of it. So we know we need to find h prime and h double prime, and maybe that's all you really have time for, where it doesn't require like a lot of thought. So like just do your h prime, h double prime, and then move on to the next part. And then if you have time, go back and do more of it, you know, but always make sure like you get at least something, some component of it that you can work on. All right, so we have, so I'm just going to rewrite h here. So h of x is 2x squared minus the integral of 0 to 2x of f of t dt. So I want to take the derivative, so that will find me h prime. So 2x squared, that derivative is just power rule, so that's going to be 4x. And then the second piece here, so this was the second fundamental theorem of calculus, so this was in our chapter 4 as well. So if you've forgotten what that is, make sure you go back and review it. So when we go and we take that derivative, we know the derivative of an integral is just going to cancel, right? And so then you're just going to substitute that t value for 2x. So then that will be minus f of 2x, but then times the derivative of what you substituted in. So I substituted in 2x, and that derivative is 2. So then there's my h prime of x, and then I'm going to go ahead and find h double prime while I'm at it, because I know I need both of those, yeah. So then h double prime, so then I will take the derivative of 4x, so that's just 4. And then 2 is my scalar, so I'm going to put that 2 there. And then the derivative, so that's this 2 right here that I wrote in front. Derivative of f is going to be f prime of 2x, and then again chain rule, so times another 2. So there's h prime and h double prime. And so then the second component, so after we found both of those, then we need to go and evaluate both of those at 1/2 c. So I'm going to go ahead and do that right next to them. So h prime of 1/2 c. Oops, being persnickety there. All right, so then that will be 4 times x, so 4 times 1/2 c. And then minus 2 times f of 2 times 1/2 c. And so I do have to keep going because they say in terms of c, so I'm not quite there yet. So this is the part right here that's not finished because that's not in terms of c but f of c. So I need to go one step further on that. So half of 4 is 2c, and again I didn't need to do that. And then minus 2 times, and then this will be, oops, I've just realized I forgot my 2, so let me get that in there. So 2 times, so that is the same as f of c, right? So half of 2, so f of c, and then again I know from this guy right here, even though this says g of c, it's an intersection point, so that means it's also the point on f of x. So that means when x is c, my y is c as well, so then that would be 2c minus 2c, which is 0, okay? So that means that at 1/2 c, right, h is a critical, or at, that's poorly worded, and I want to get more points. I'm gonna say that better. Like I just realized, like that, it's not gonna come out the way I want to. So I would say at x equals, let me say that better, 1/2 c, it is a critical number, right? And that's because that derivative is equal to 0. So I know it's a critical number at this point. All right, so then let's go ahead and find h double prime. And why did I even do that? Because I saw that I'm looking for relative maxes and mins, and so that's important, right? So if it's a critical number, then it's either going to be like up here or down here, right? Because that's where the slope of the tangent is 0. So then let's go ahead and find h double prime. So h double prime of 1/2 c. So that would be 4 minus 2, and then times f prime of 2 times 1/2 c would just be c, and then times 2. So that would be 4 minus 4 f prime of c. All right, so now I have to figure out what is f prime of c, okay? Because it does say to do this in terms of c. How would I find f prime of c's value? So it would be, so right here, and so I'm looking for slope, but I'm not sure I would know how to find that value because I don't have anything to the right of it. Well, that's interesting. Okay, so I don't know how to find that f prime of c. Like the only thing I know for sure is that it's a negative number, right? Because it's down, it's decreasing. Maybe that's just a, we're going to say that's just an oversight on their question. So like that in terms of c component, because I wouldn't know how much further to go. So I would have to leave it like that because I really don't have any idea how to find that f prime other than I know it's negative. So we're just going to call that one good. And I will go back and look at the answer key and see like, well, am I not seeing something? Okay. All right, but let's go on to that last part of that question. So it says, does the graph of H have a relative min, relative max, or perhaps neither? So we know that it's got to probably have something, and so so what I need to know is for that critical number that I would have a relative max if the graph was concave down, right? So that means f double prime, oops, not f because we're in H, so how about H double prime would have to be negative, and then that means I'm concave down with a tangent line, so that would give me that relative max. Or I would have a relative min if H double prime was greater than 0, meaning I have a concave up, right? And that was called the second derivative test, and that was in chapter 3. Okay. So I need to figure out, are we negative, are we positive? So this comes in handy actually, so that was pretty good. So this piece right here that we said where it's negative, that kind of comes in handy. So then what I can say is the fact that I have this value is negative and we're subtracting, so we have that double negative. So like no matter what, we're going to be saying that H double prime has to be a positive value, right? This has to be greater than 0. Why does it have to be greater than 0 again? Because this is 4 plus 4 times a number, right? And that turns into a positive here because I have that double negative. So then because the second derivative is 0, because the second derivative is greater than 0, this is the situation I have. So then my conclusion would be that H has a relative minimum at x equals c over 2, and that's because H prime of c over 2 is equal to 0, and H double prime of c over 2 is greater than 0, and that would be all we would have to say. Okay? And then I'll do the other parts on a second video.